Okay, so in exercise 3F, we are now going to look at geometric sequences. So a geometric sequence, so remember we have a sequence and we have a pattern, and the same thing is happening all the time. When we had arithmetic, it was you were adding or subtracting the same thing every time. When we have geometric, it's you're multiplying by the same number every time. Okay, so that's what geometric is. Okay, and just so we're gonna just so you're gonna know, so it's in your notes handy, I'm gonna say right on the side here, if you multiply by a number less than 1, so say, for example, if you multiply it by 0.2 or 0.3, if you multiply by a number less than 1, that's going to be a decreasing sequence. So the numbers will keep getting smaller, okay? So that's what that is. And then if you multiply by a number bigger than 1, so, you know, in 1.1 or so on, 2 and all that. So if you multiply by a number greater than 1, we'll say it's you'll have growth. It's going to be a growing sequence. I'm going to write growing sequence because you're going to hear, you know, that's what we're going to see. We're going to see growth situations, and we're going to see depreciation situations. And what do you think depreciation is? A decreasing one. Yeah, depreciate means gets less. All right, so we'll see that later on. So let's just go through this. So in a geometric sequence, a new term is made by what we just said, multiplying the previous term by a number. So that's what I just said. So if you multiply it by a number greater than 1, it'll grow. If you multiply it by a number less than 1, it will get smaller. And what that number, the multiplying number, is called the common ratio. So if you just probably want to, we'll just highlight that and maybe just write, yeah, we'll do it. This is the multiplying number. Okay, sorry. So just for example, maybe here we'll just write, so say e.g. R would equal, I'm going to just make one up. So R would equal 0.9 because that would be. And then if you had an example of a greater than 1, R will equal, I'm going to say 1.2. Okay, that would be the common ratio that you're multiplying it by. All right. So so we can have a look down here at we're looking at a couple of sequences here. So we start with the number 2, and then if we multiply by 3, we get 6, and then we multiply 6. So there's that 3. So in this first example, we're going to say our common ratio, R, is 3. It keeps going multiplied by 3. And then in this bottom one, they're halving it all the time. So we could say the common ratio is actually 0.5. So I'm timesing it. I'm just changing it to a decimal number. We won't use fractions. We'll use decimal numbers because we're going to work in finance. So we'll definitely be using decimals. Okay, so in a geometric, if we want to find out what the common ratio is, so this is, we want to find out what R is, you can take any term and then divide it by the previous term. So say, let's have a little example here. If I took like, I'm just going to show you. So if I took 18 and I divided by, so if you see, I'm saying R would be 18 divided by the previous one, which is 6, which is 3. So you can see it does work. You'll find the common ratio. And then if I looked at this one, if I did say 15 divided by the one before, so 15 divided by 30, you'll see you get 0.5. Okay, so that's the way you can find the common ratio if you're just given the sequences of numbers. Okay, so let's have a look at this. It says, which of the following is a geometric sequence? So if it is a geometric sequence, so if it is, it will have a common ratio, yeah? So, and we know that's the R, you know, the big capital R. So I'm going to see, right, so if I found the R, I do one number and I divide by the number before. So I do 9 divided by 3, which is 3. Then what you do is you've got to test the next one. So if I test the next one and say I did 12 divided by 9, does that equal 3? No, it doesn't, does it? It equals, what's that? 4 over 3, yeah? So it doesn't equal 3. It's actually 1.33. So because these are not the same, yeah, because not the same, it isn't a geometric ratio, the sequence, sorry. Okay, so that's not the same. So that one's not a geometric sequence. If I look at this next one, so first I'll do the first set. So 4 divided by the one before equals 2. If I try another one, 8 divided by the one before, it also equals 2. So they're the same, aren't they? Yeah, they're the same. So yes, this is a geometric sequence. So you've got to test it. If you need to, you've got to test a few in a row to make sure that, you know, they're all going up by the same ratio. So, and then the next question, it just says to find the common ratio. So if you just do capital R, so we just need to find it. So you can just do 12 divided by the one before, which is 3, which equals 4. You could test it if you want, but if you've done any other numbers, so if I did 48 divided by the one before, you're still going to get 4, okay? Try to, if they're just asking you what, if they're telling you it's a geometric sequence, just do. The start one is obviously smaller numbers and easier. All right, so let's have a look at this one. Find the common ratio. I could do 8 divided by 16. So that equals, you know, 1 over 2 or a half. You can do them on your calculator. You don't have to, you know, work it out in your head. And if you want, you could test another one. If I do 4 over 8, that also equals 0.5. Just as this page is just going over on your calculator, so you can still create that sequence the same as like what we did with the arithmetic. So for the example here, they have taken, they're going to multiply, if you look, the R value is 3. So when you want to keep on finding the terms, like, you know, the sequence, so what they did is they typed in 1 and they pressed enter. And then when the next line, they press times 3. And what comes up is answer 3, and that's what you want. You're going, yes, you want the answer before to be times by 3. And then you press enter, and you'll end up seeing this. And then if you just keep pressing enter from then on, it will keep bringing up the sequence for you. It automatically does it. So that's a lot handier to know, and it'll make you a bit quicker in your tests. Okay, so consider this sequence, this geometric, so 2, 6, and 8. Find the next term. So if you look at, it said geometric, so let's work out what the R is. So it would be 6 divided by 2, which is 3. So to get the next term, it would be 18 times 3, which is, what's that, boys? 54? Yeah? And then it said construct a table of the term number n and the value of that term for the first 4 terms. So 0 was 2, term 1 was 6, term 2 was 18, and term 3 was 54. Now it said to graph, and then it says then plot the graph. So it's already there on your graph, but I'm just going to show you. So if you draw those dots together, you'll see you end up like that. So we want to make a note here that it's a curved line. So when it says this is a curved line, so geometric sequences will have a curved graph line on the graph. So geometric sequences will have a curved line. So if you remember back, arithmetic will have a straight line. So geometric has a curved line. So this one, it's curving down. So this is a... Oh, sorry. That's this example. Sorry, this is about it. This is not the graph of this one, is it? No. So this is that. So if I have to, I'm going to graph this one over here. Sorry. So let's graph this one. If I had 0, term 1, term 2, term 3. So this would be the term number. This is going to be the value. I'm just going to roughly do it. So it was 2. So say I start there. Now it curves up. It goes really big quick like that. So we'll just do it like that. Okay. And so you can say that's 3 and 54. And we can just, you can just draw a curved line and then mark them in. Okay. That's fine. So 2 was 18. 1 was 6. And this was 2. Okay. So this one, sorry, boys, this one, I'm just putting this on the video too. This one is not that example. This is just another example. And to talk about the curved line. So this one, if I drew the table, let's put the table in here for this one so you could see. So if this was n and the value, we'd have 0 and it looks like it was, I'm going to say 32. Oh, sorry, 32. Then we had 1, which looks like it's at 16. We had 2, which looks like it's at 8. Yeah. And we had 3, which looks like it's at 4. Okay. So that's this one. So if you want to write another little note, this is an example of growth geometric sequence. So this one, and this one is an example of depreciation. I'm going to write a depreciation geometric sequence. And if you want, just write under the word depreciation decreasing, so you understand it's when depreciation is the word they're going to use for reducing or going smaller. Okay, so this is just summarizing it up. The graphs of geometric sequences for R is if R is positive. So increasing when R is greater than 1, that's what we just talked about. So this little language here, that's just the way they say that if the R number is bigger than 1, okay? That's just the way you can mathematically say that. And then the same, if I want to say it's decreasing if it's between less than 1, between 0, okay? All right.